So let's hear it from Vince on how we can all make super happy modern HTML5 games.
Thank you very much. I like video games. I hope you all love video games. You love making video games. We're here to talk for 30 minutes about making video games using browser technology. Everything coming directly out of the browser, no plugins needed, no batteries not included, nothing else. It's all ready to go right from the browser. The slides that I'm showing are implemented in HTML5. They're available on a website right now or later when you go home and you want to follow up on any of these references. So don't worry about that. Just jot down CC 2011 HTML5-games at the AppSpot domain. So I already got a great introduction. I'm Vince. I'm an engineer. I'm mostly a C++ kind of guy, but I'm empowering games who are using these new browser technologies, and so that makes me feel real good. I've been doing games for about a decade now, and I'm pretty easy to find online if you want to look that up for any reason or get a hold of me. So just to kick things off, let me turn up some volume here. We're going to have a bit of audio. Hopefully that'll play nice. This is just a bit inspirational. I'm going to launch a website, and let's see if we have internet connection. Awesome. So here's a little bit of just inspiration to kick things off. Loading, well, that does come with the internet, doesn't it? This is basically an interactive music video, and it was done by a couple people. Danger Mouse was involved. I'm a big fan of his music. Other people were involved as well. Everything that you're seeing here is running inside Chrome, and
touched the walls of the city streets and didn't explain, sadly showed us our ways. I've never asked him why. Cast down, it was heaven sent to the church.
So the cool thing about this is everything you've seen so far is basically video, but as we crash on through this wall, we break into an interactive experience. This is using WebGL, 3D graphics live in the browser. And I can control the direction that we're looking, and by doing so, also the geometry that's being created in this environment. So all the green and morphing and animating geometry is all interactive. I can direct where that grows in the world. And so I just love this because it's got really good production values and is showing off what the web platform is capable of these days. I don't want to burn too much time on it because I have a lot of other demos to show as well. So let's move on a little bit. But that's really cool. Big new experience that you can get on the web today. So let me give you an overview of what we're going to be talking about. I'm going to give you an intro and tell you the main motivator for using web technologies, and that's reach. Get to more users, more potential players of your game. I'm going to go over the anatomy of a modern HTML5 game using a case study. I'm going to talk about some of the capabilities of the browser platform. I'm going to discuss monetization and distribution. I'm going to give you a lot of pointers for engines if you want to go off and do your own work, and a couple additional tips to learn more about the topic if you need to. So why do you care about browser technology? You care because you can reach a very large number of users. Everybody's using a web browser every day. Almost half of those users can play HTML5 games. So this particular statistic is coming by looking at the browser share for the different versions of Internet Explorer, Safari, Chrome, Firefox, and counting up how many of those browsers can run an example, in this case Angry Birds, and half of them can. So half the users of web browsers can play Angry Birds using just HTML5. That's pretty cool. Chrome alone has over 160 million active users who are coming back to Chrome and using it frequently. That's pretty big. That's twice as large as the Wii platform. So Nintendo Wii has sold half of that, and that's just units moved. That's not the users who are actively using it. So even if you just think about Chrome, you're reaching a huge audience. So that's really, why you want to move onto this platform. So let's talk about what is this platform. Using Angry Birds as a case study is a good way to do it. You've probably seen Angry Birds before. An excellent game. It's been very popular on the mobile platforms. It's available on the web as well. So here's a version running in browser, and it does what it should do. You got birds, and you can throw them at pigs and stuff. I didn't claim to be good at this game. But anyway, there it is. So what does it take to make a game like Angry Birds on the web using no plugin? Well, they started off using the Google Web Toolkit. If you haven't heard of this before, it's often referred to as just GWT or GWT. It's a technology that allows you to develop a larger application using Java and a robust IDE, and then compile that down into JavaScript delivery. It has a lot of optimization built into it as well. For their physics, obviously, they're using a physics solution. Box2D is their answer there. For graphics, they're using WebGL. WebGL, I'll go into more details later, but basically it's a 3D graphics API. And even though their game is 2D, they're using WebGL because of the excellent performance that it can provide. Oops. Let me click on this actual application. So here I have just a simple example running WebGL, a nice car, and I can drive it around. It's interactive. So there's some cool demos out there of what you can do with WebGL. Not all browsers support WebGL, and so they have a fallback using Canvas. I'll go into more details on that later as well. It's a 2D drawing API. They also use HTML5 app cache for offline play. So if I was not connected to the internet, I'd still be able to play Angry Birds, which is kind of cool. They use App Engine for hosting. App Engine is not really a web platform technology. That's a server-side technology. App Engine happens to be a service from Google. You could, of course, use a lot of other hosting services as well. App Engine is really easy to use, though, and it scales very well. It makes it very easy to have highly scalable games. They also used a middleware library called 4Play. 4Play works with the Google Web Toolkit and provides some additional abstraction and allows targeting applications for the desktop web browsers, Android, and Flash. So that's pretty cool. Angry Birds is the biggest production game that has shipped with it and has shipped only to the web. I think the other platforms haven't yet had such a large game launch yet. But it is open source, so you can check that out if you're interested. So that's just an overview of one game and what technologies they used. I want to run through a variety of those technologies in a little bit more detail and give you sort of the capabilities of the web browser platform. These are, a lot of technologies just kind of one right after the other, so we just kind of run through them all. So sorry for the somewhat discontinuous slides here, but we'll start off with graphics. It's a very good place to start for games. I mentioned WebGL earlier with Angry Birds. WebGL is basically taking the OpenGL interface and putting it in the web context. They started with the OpenGL ES2. That's a more restrictive API. So OpenGL has been around for quite a while in the desktop world. It had a large and fairly bloated API. And when it was moved onto the mobile device space, they wanted to trim that down so there was some smaller implementation possible. And so that is the ES for embedded systems. So that's the API that has been made available on the web, and you can access that through JavaScript. And basically all the documentation or all the know-how you need comes out of your standard OpenGL books. So a lot of developers who already have OpenGL capabilities can quickly develop applications using it. It offers textures, frame buffers, blending, all in a low-level GPU API, as well as vertex and fragment shaders using the GLSL shader language. It is formally specified via the Kronos group, and the 1.0 specification was launched this year at GDC. Canvas is a completely separate API. The 2D Canvas is a drawing API that can handle images for sprite-based games, but it can also do vector-based drawing. So you can have paths, fills, gradients, text, etc. It's an imperative API, so that means that you provide instructions every time you want to draw a scene. There's no retained scene graph or anything of that nature. So again, it's fairly simple and straightforward. It is very easy to pick up, and a lot of games have done so. It's very popular with indie games right now and hobbyist games, and we're starting to see some additional games come over to it also. It is supported by a large number of browsers, including, for example, Internet Explorer 9. And several browsers, Firefox, Internet Explorer 9, and Chrome, have implemented GPU acceleration for Canvas as well. So even though the API is higher level than a low-level GPU API, the rendering is being offloaded onto the GPU and providing significantly higher performance on the machines that can handle it. On the machines that can't, it does fall back to software, so you can run this on a very large number of machines, including mobile devices. Your graphics don't look as good without really good sound, and so I want to point out a very important upcoming API launch called the Web Audio API. The web audio, well, audio on the web has existed in HTML5 for a little bit. There was the introduction of a video tag and an audio tag to make it very easy to include media on a web page the same way you would include an image. The audio tag, however, was really designed for playing back, for example, a 5-minute song, and it wasn't really designed for game needs. The Web Audio API has a lot of really cool features. It's very high performance, very low latency. It has sample accurate scheduling, so you can have very complicated mixes. It does spatialization in 3D, Doppler effects, convolution. It gives you frequency analysis if you want to do visualizer work. It has filtering and compression ability. This is all in a configurable node graph, so you can do some pretty complex mix work. And you can even do raw synthesis or processing of your audio samples in JavaScript if you need to or want to. And there are demos of that in both real time and also pre-canned work. So there's a demo I want to show off for the Web Audio API. Let me just launch that up. This is just something somebody hacked together on the internet called Tonecraft. And I have no idea how to make sound that sounds good, so I'm just going to kind of click randomly here and see if I can make anything that is like, not too crazy. And so the catch here is that all these blocks are placed in a simple lo-fi way, the way Minecraft would be. But you can see that as I do that, I start getting like fairly rich sound environments, which isn't really capable, which isn't a possibility of any of the pre-existing audio APIs at this performance and quality level. Cool. That is a very awesome audio solution that's just becoming available. It will be going into the stable channel of Chrome this fall. It is, of course, an open web standard, and it has an implementation started in Safari also. WebSockets offers networking capability. So the web is, of course, all about networking. What's new here? Well, WebSockets are a client-server technology that offer low latency, persistent, and full duplex connections. So you can have experiences that weren't really possible using a lot of the previous HTTP request styles. It can upgrade from an HTTP handshake, though, which is pretty cool. So it kind of rides on the same infrastructure backbones that the internet already has in place. Right now it pushes UTF-8 string data, although binary data is being developed and will be on the way, so we can get higher throughput. It's also very easy to use. I have a little bit of code here if you're a coder, showing you, how easy it is to set up WebSockets. And just some examples of things that people have done with this. Let me see if I can pull up the multi-user Sketchpad. There's a very cool guy named Mr. Doob, and he does a lot of interesting projects. This is one. He has a sketchpad where you can draw on the internet. I, of course, cannot draw, even if I'm on the internet. But no one else is here, and this is sad. Okay, other people can be here, and if anyone else is drawing on his sketchpad at a given time, they can see this on the internet. And so I could mock that out, but I think I'm not going to bother. Anyway, the concept is that you could have dozens of people all drawing on the same canvas at one time. So I'll show you another example. This is a small game I helped a guy named Greg Tavares on. His idea was you should be able to walk into a room and have some cool game playing. So in this case, up on the projectors, we have a simple shooter game where you just have little triangle ships, you fly around, shoot little bullets. So we called it Pow Pow. And the idea was it just has a URL. You type in the URL on your mobile phone or on your laptop, and bam, you've got controls for the game. But you're not playing the game on your device. Your device is just your controller, and it uses WebSockets to control your ship up on the shared screen. So in this case, we had about a dozen people all playing this game at the same time from different machines. They just hop in, hop off. And the WebSockets gives great, tight, can turn any web browser capable device into a game controller. So pretty cool. I mentioned that Angry Birds is available offline. They did that using the application cache. The application cache is a way for you to communicate with a browser and tell it what resources should remain available even if the browser is offline. So if I am risky here, I can unplug my internet connection and I can pull up a page and try like, hey Google, uh-oh, I can't connect to the internet. What am I going to do? I can't check my Twitter feed. I know. I'll open up a new tab, and I've got Angry Birds. At least I can kill some time playing Angry Birds. So I pull up Angry Birds, and here it is. We're ready to play offline. They mentioned that at the bottom of the page. And yeah, there it is. So very powerful, very important, especially for games, because it gives people something to do when they can't get access to email. There are some details that you can look up if you're a technical person in terms of how the application cache works, but that's the real point, is it gets your game available offline. However, that's just caching your resources that were available on a server. If you want to actually modify local state, there are some old ways you could do that using browser technology with cookies and things, but they really weren't a great solution. IndexedDB is a transactional database that's sandboxed and under your control. It has very good performance. It is indexed, so you can have a large amount of data and search efficiently through it. It's an asynchronous API. If you're using a worker thread, otherwise like multi-threaded JavaScript programming, you can use a synchronous API just for convenience. And you can store a lot of good data there, which is excellent for your level progression or user-generated content or things like that. However, if you have really large data, that really isn't suitable for a database, perhaps your enormous game assets. Let's say your game has a gig worth of assets, and you want to be caching those in the background. Like you want to start up your game, have an awesome intro experience that loads right away, but in the background you're loading all those big, heavy assets that you're going to need for future play. Or maybe you have an MMO where you're traveling a very large world, and you're caching the resources needed for the local proximity of that world. You can do that. You can micromanage that using your own code and implement that with the file system API. It gives you large file storage in a virtualized file system under your control and sandboxed per origin. So also very powerful. I need the internet, so let me plug back in for this demo. Reload this. So here's a simple terminal that you can't read, but this is like a Linux terminal, and I can do an ls, and oh, look, there's a directory structure. Let me make this a little bit easier to look at. I'll type 3D, which gives us, oh, this is Unix. Cool. Okay, I know Unix. So like I can cd into user, and like, okay, cool, there's a directory. Let me just like add a file. So here's just a random file the user had. It's an image. Let me drag and drop that. And oh, cool, I just put it into my local file system store. And I can, for example, open that as well. So I can open this BB JPEG. And oh, I blocked the pop-up. That's kind of annoying. OK, let's allow the pop-up. Oh, cool, it was an image. And so this image, you can't read this URL, but the URL is file system. And then it's the origin, which is just the domain and origin of my web application. And then it's got the local file path for that image. So very cool. There's a lot you can do with this, and I think for big, significant games, they're going to be using this to very intelligently manage their asset deployment. There's a lot more the web can do. I'm just going to give a really brief overview of these things. There's geolocation. You can ask, where is this device? That works on laptops too. It might, for this laptop, it might only have city level information, whereas on my Android device, it might have more specific, location information. You can get orientation of devices as well. There's web fonts. So if you have dynamic content or you're just optimizing bandwidth, hey, deploy the font. Don't burn everything into a raster image. So that's pretty cool. Google has a very large library of fonts that you can use, and you can easily host your own. There's also CSS 3D, so you can do a lot of styling using web technology and cascading style sheets. CSS 3D has 3D transformations available and animation, so that's kind of cool. So I've got this little element that'll animate when I hover the mouse. And there's also another rendering API called Scalable Vector Graphics that is a retained scene graph-based DOM-like rendering API. It's primarily oriented towards vector, although of course you can put images into it as well. It's heavier weight than Canvas, but it might be the right solution for you depending on your game. So it's worth checking out if you're looking through all the rendering options. And there's one last thing I should cover, and that's a native client. I am cautiously optimistic that this is going to be enormous, enormously huge. To date, all functionality that you get from applications on the web either run in JavaScript or they run server-side. If you want high-performance computing, you have to push it to the server. If you want it really local, you're stuck with JavaScript, and JavaScript is really cool. You can do music visualizers, you can do 3D physics, but just not a lot of objects. Native Client gives you the ability to run native code from C++ as pervasively as you would run JavaScript. You can take your legacy code base and run it. How do they do it? It's sandboxing technology. It's been in the works for quite a while. It's an open source project. It's shipping in Chrome. Developer preview is available right now. It's being released this fall. Last year, we demonstrated the Unity game engine running plug-in free using native client. This could be really, really big. So if you haven't noticed it yet, you should notice it and take a look. I'm running out of time, so let me fly through some other things. Monetization. Hey, Google just launched a in-app payment API. It's very easy. It has very low fees. That's it, just a 5% transaction fee. There's nothing else. The API is very simple and straightforward to use. So if you're looking at your options for in-app payments, here's a good one to consider. We also have a web store. It's an excellent way to get distribution and discoverability for your content. The web store has some great features like no upfront app review process. Some really big companies, all the way down to indies, have been using it already. And if you're a smaller developer and you want to do an initial slow roll with your tech, you can target Chrome and the feature set of Chrome, which tends to be kind of the leading, shiniest features on the web. Get your game out there, get it awesome, and if you host yourself in the web store, you know all the users coming to you are using Chrome. So you don't have to worry about cross-platform support until you want to expand to other distribution markets as well. We have some awesome success stories there already. In World Golf Tour, they noticed that users play the game more, the users buy more content when they come to that property through the Chrome Web Store. We noticed that in the realm of the Mad God, it's early days so far, but so far the users have been twice as sticky as the other discovery methods. So very promising results. The apps model works on mobile devices. Users like it. It works really well in the web browser as well. So most of this I'm going to leave for you guys to look up on the slides afterwards. There's some really cool engines. Go check them out. Some of them have been bought by big companies. So the acquisitions in this space give you some of the intent of the kind of interest from large companies such as Disney and Zynga. You can also package your HTML5 applications and deploy them on mobile. There are a couple options to do that. PhoneGap, Game Closure, Spaceport, the Impact engine deploys to mobile as well. You can also go the other way. There's a company called Mandreel that is porting C++ apps from iOS devices and bringing them onto HTML5 tech. So very interesting. I think we'll see a lot of games be moved over in that direction. There's a lot of good resources for learning. There's 2 conferences I'll point out. On Game Start in September in Poland, and New Game, a conference that will be co-hosted by Google that's going to be in November in San Francisco. There's a lot of blogs you can read, there are books, and all that. Let me wrap it up with just going over a couple of the challenges. Tools. There aren't as many tools right now for the web platform, so I'm looking forward to seeing more of those tools being developed. Engines are certainly on their way. There are multiple implementations. No one institution controls this platform. There are open standards, and we are honing in on standards that are universally supported. It's awesome to see Microsoft, and especially with Internet Explorer 9, adopting so many of these standards. But as a developer, you do have to deal with multiple implementations. And there are proprietary alternatives. So that is a threat to this open platform, and we'll see how that pans out in the future. The potential is really large, though. The reach is huge. You're not going to get larger reach. The open web standards are adopted by more devices and more platforms because they're open. And so you have the potential to reach far more users than using any other technology. The friction is very low. When the technology you need is either built into a browser or deployed via JavaScript or native client code by you, the user needs to do nothing else. So there's no friction, there's no resistance to them playing your game. They see that awesome link, their friend said, "This game is so cool." You click on the link and you're playing the game. Maybe you're playing the game with them. It was an invite to the game. There's nothing else to install, no permissions, no security concerns. That's really big. Open standards back all that up. So thanks. The slides are online, and I hope you have a great conference. Any questions?
Thanks, Vincent. We've got time for maybe 1 or 2 questions before we move on to the next conference. Yes?
Can you give us the URL for the slides again, please?
The URL for the slides, the URL is cc-2011-html5-games.appspot.com. CC for Casual Connect -2011-html5-games.appspot.com. You could also just search, for example, you could search Vincent Scheib or HTML5 games. There are a lot of really good resources that'll get you to these slides or very similar slides.
And we should be putting all the slides from the Casual Connect conference up online as well, so you can check there as well. One more question?
So the question is, hey, what's the different support for all these individual technologies? So it varies. Canvas, for example, is very widely supported. WebSockets is fairly well supported. There's a resource that these slides point to, but there's a website called caniuse.com that's really cool. It goes on a per technology basis, and it'll show you the different versions of all the different browsers that support an individual technology. So, for example, with WebSockets, you can actually do, a query for WebSockets, and you can see, okay, IE does not support it yet. Firefox has supported it since 4.0 with some limitations, and fully supported in 6, Safari in 5, and Chrome since 10. So, yeah, there are definitely resources to help you learn component by component what it can do. Awesome.
Great.
Thank you very much, everyone.
Great. Thank you.